When I'm teaching differential equations, this is my favorite differential equation to talk about. And the reason why is because I can solve this in a myriad of different ways, which demonstrates the entire course. So let's go ahead and start with the easiest one. And this one is guessing. And that is y is equal to e to the x. And we know here that y of 0 is equal to e to the 0, which is equal to 1. And so we have solved this by guessing. This is a perfectly valid way of solving a differential equation. We found a solution. Pretty easy. All right, so now let's look at another way to do this. And this way uses the separability of this differential equation. And all I do is I multiply over by dx and I divide by y. So I get dy over y is equal to dx. Then from here, you just integrate both sides. And you get natural log of the absolute value of y is equal to x plus c. And we're just going to assume that y is positive. At the very least, we know y is positive here because it starts positive. Exponentiate both sides, and you get y is equal to e to the x plus c. Y of 0 is equal to 1. E to the 0 plus c is equal to 1. And so then, if I want to figure out what c is, through logarithms, c is equal to 0. So again, we get y of x is equal to e to the x. Done. Now let's treat this as a first order linear differential equation. dy over dx minus y is equal to 0. So I multiply by something that will spit out a negative 1 when I take its derivative. And so that's going to be e to the minus x. I multiply both sides by this. And what's really cool is that if I were to consolidate this minus sign in with this guy, so what I'm really seeing is a result of a product rule. And so then we get dx of e to the minus x times y is equal to 0. Integrate both sides and multiply both sides by e to the x. I get y is equal to c times e to the x. And if I set y equals 0, we see that c then has to be equal to 1. And our solution then is y of x equal to e to the x. And now let's take a look at another thing we can use. And we can use power series. If I have y is equal to sum a n times x to the n. So I get dy dx is equal to sum n equals 1 to infinity of a n times x to the n minus 1. Reindex this and it starts at n equals 0 to infinity and move everybody forward. So that tells me that our a n plus 1 times n plus 1 times x to the n should be equal to the sum of a n times x to the n. And so we get this nice recursion. And so then that means that I have a n plus 1 should be equal to a n divided by n plus 1. A of 0 is 1 because if we put y is 0 in for x, a of 0 is equal to 1. A of 1 is equal to 1 divided by 1. A of 2 is equal to 1 divided by 1 times 2 because it divides this guy by 2. A n is equal to 1 over n factorial. So then y is equal to the sum of x to the n over n factorial, which is equal to e to the x.